In flow code program, we have analog input. That can vary from 0 to 5 volt, and we can convert these voltages into two digital formats, that is 8-bit resolution and 10-bit resolution. So PIC microcontroller, that is PIC 16F877A, has 8 analog inputs. So we can connect 8 analog inputs with our microcontroller from analog 0 to analog 7, and we will see how we can read these voltages, that is from 0 to 5 volt, as 8-bit conversion and 10-bit conversion. So let's start our first program to read the analog voltages in flow code. Now we'll create a new flow code flowchart. Okay. And we will select 16F877A microcontroller as we have selected in our previous sessions. We can select other microcontrollers also as per requirement of our project. So, but for learning purpose, I am using 16F877A. Okay. Now we have a panel and our main program sheet starting from main, and we have a loop that is begin and end. As we know that analog variables are inputs, so we'll go for input section and I'll place ADC. Here I have a variable resistor, that is ADC, on my panel. I can go for its external properties. Here we can see different properties of my ADC. Acquisition time is 40 program cycle. Conversion speed, frequency of oscillation, divide by 8. We can select some other option, that is divide by 16, divide by 32. If our signal is slow varying signal, so we can go for F oscillation divided by 16, 32, 64 or 128 and so on. V reference is VDD, that is 5 volt. Here we can see we have a knob type and we can also have slider type variable. We can increase its length. We can increase its width, and we have different types of sliders, slider 1, slider 2, and we can also give a custom shape to our slider, but I'll go for style 1. We can also assign a label to our analog input, say for example temperature, and we can check show value box, so it will show the value that is from 0 to 100%. If I'll apply these properties to my ADC, apply, OK. Here we can see we have a variable resistor, that is temperature, and its current value is 0. Now we learn that how can we read this analog value in our microcontroller. So first I'll place 8 LEDs on my panel to check the digital value of my analog variable. So I'll go for outputs and I'll select LED array. Here we have LED array, and I'll connect this LED array with port B. Okay. Now we have port B from port B0 to port B7. I will read the input of my variable resistor and I'll show my converted digital equivalent value on LED. So first I will place a while loop in my program, and I'll place a macro here. Here we can see we have two components, that is ADC and LED array. If I'll click ADC, we have many options as macro, that is read as byte, read as integer, read as voltage, read as a string, ADC raw configure channel, ADC raw sample channel byte, ADC raw sample channel integer, ADC average channel byte, ADC average channel integer, ADC raw disable channel. First we will select read as byte because we would like to display the converted data on 8 LEDs. So we will select read as byte. Okay. Now I will give a variable that is written byte. Here I will assign a variable that is ADC val. Initial value will be 0. Description analog to digital value 1. We can say ADC val underscore 1. Okay. And the variable type will be byte. Okay. Now I will double click this value and it will be displayed in my written value block. Okay. It means that I am reading the value of my analog input and I am converting it into 8 bits. Now I will show the value of my ADC on port B. So I will use output and I'll select port B as the entire port and I'll select a variable that is ADC val 1. Okay. And I'll give a small delay before going to take the next sample. Say for example 500 millisecond or 0.5 second. But before starting our program, we will go for build, project option. Here we will select the clock frequency that is 10 megahertz. We will configure our chip and here I will write 3F3A. Okay. Now we'll check the result of our program. Okay, start. Here we can see all the LEDs are off and value of my ADC is 0. If I'll move my variable towards high side, here we can see the value in the digital format on LEDs. Here we can see different values. For 50%, we have value that is 127 and for maximum 100%, we have converted value that is 255, which corresponds to 100%, that is 5 volt. Or if I'll take it to 0, so we have all LEDs off.